So what we want to look at is how do we find a side if we know an angle and one side. So let's say that we have a triangle that looks like this. So the hypotenuse measures 10 inches. We don't know this side over here that's labeled X, but we know this angle down here. I heard somebody say a squared plus b squared equals c squared, but why can't we use that here? Why does that not work for us? Alex? So we only have one side. So we can't use a squared plus b squared equals c squared because we only have one side. Any ideas about what we could do? What do you think we could do? Paul, what do you think?
Well, I know the way I would have gone about it, I would have found like the sign
Why?
because we aren't actually off our angles up there and that hypotenuse.
Okay, so Paul says when he looks at this, he thinks he's going to use sine because we have this angle, and so this problem is dealing with the side that's across from that angle, which we call the what? Is that opposite, adjacent, or hypotenuse? So we're dealing with the opposite and we're dealing with the hypotenuse. So that must be sine. Okay, so could you write an equation that involves those three things? What would that equation look like? What do you think it would be? Usually we say sine and then we put some angle letter there, right? But we know what the angle's measure is. What is it? So this is a 35-degree angle, so we say that the sine of 35 degrees is equal to, and what is sine? We just said it, opposite over hypotenuse. What's my opposite? What's my hypotenuse? 10. Okay? This left side of the equation, this sine of 35 degrees, that's just a number. It's just a number. So our equation is saying, look, we've got some number that's equal to x divided by some number. If this was my equation, how would I get x by itself? Multiply by what? I could multiply by 6 to solve this one. So in this equation that I'm actually looking at, what am I going to multiply by? I'm going to multiply both sides by 10. So I'm going to multiply by 10 on the left. I'm going to multiply by 10 on the right. That's going to give me x on this side. Okay? When I go to my calculator, I need to be very aware that right now the pre-calc classes are working in radian measure. And so they are almost always going to change the settings on my calculator to radians. You guys are dealing with degrees. So really the first thing you should do when you go to the calculator is you should go to menu, nope, sorry, I do that wrong every time. You should go to documents, number 7, settings, number 2, document settings. All right, so where did I go? I went to document, right? And then I went to number 7, which is settings, and then I went to number 2, which was document settings. And I want to make sure that the second thing down is degrees, and I want to tab until the thing that says make default is highlighted, and I want to make it default. So I'm going to go down till make default is highlighted, and then it'll say, do you want me to apply this and save as the default? And so it says, applying your settings to open document and save them as default for new documents and Scratchpad. And I say, okay, because that is what I wanted to do. Okay? So now, when I do that calculation, 10 times the sine of 35 degrees, I don't have to worry about whether or not I put in a degree symbol. So I do 10 times, I go to my trig menu and get sine. I put 35 in here, and it doesn't matter now if I put a degree symbol in because I've changed to degrees. And so I press enter. Oh, yes it does. Huh, wonder why it did that. Okay, so I'm gonna put a degree sign in here. I wonder why it didn't use degrees, because I told it to. Oh, stop it. Excellent. Get out of there. Oh wait, is that right? No, that's right. Okay, so that side measures about what? So how many decimal places do we want to be accurate to? 3. It is. I know. It was okay. It was right. So I got 5.736, right? Which makes sense. I figured out that side x is equal to 5.736. And since this side is inches, my answer is in inches. Okay? Does that make sense? Okay, so now if I know that this side is 5.736 inches, could I find this side down here?
Yeah.
Okay. Do I have more than one way to do it? Could I use the Pythagorean theorem? Yeah. Could I use a trig identity? Could I use like sine, cosine, or tangent? Right? Okay. Could I figure out what the measure of this angle up here is? How? You have 2 already. What do they have to add up to altogether in a triangle? They got to add up to 180, right? What's this one? So if I did 90 plus 35, that'd give me 125. And if I take 180 minus 125, I get 55. Right, so that would be a 55-degree angle up there. So far, makes sense? Okay. So there's one other kind of problem. No, that one doesn't work like that. Okay, hold on. Sometimes you're going to have a triangle, and you're going to know this side and this side, and the problem might say find angle A. Okay. This is a little different than what we've done before, right? If I want to find angle A, then first I have to find out which one of my ratios it's involved in. And then I have to use a special feature on my calculator. This is like, do you remember the first worksheet we did when the back of the sheet had that list of sine, cosine, tangent, and you looked up the value? So like if you knew that the sine of angle A was equal to 0.5, then you went to the sine column and you found 0.5, and then you went over and said, oh, that's a 30-degree angle. Do you remember doing that? Well, your calculator can do the same thing, right? So if you still have that worksheet, I kind of want you to play around with it for just a minute. But if I go to my trig menu and I do sine inverse and I put 0.5 in here, then my calculator is going to give me the same value that that table did. Okay, do you see what the calculator is doing? So I'm saying, hey, calculator, if 0.5 is my sine, so if I go down the sine column to 0.5, what angle is that going to be? And the calculator says, oh, that's going to be a 30-degree angle. All right, that's called using the inverse functions. All right, so go back to my example. I want to find the measure of angle A in this picture. So which one of my ratios involves angle A and its, what's that called? Its opposite side and its adjacent side. Which is that? Tan. So the tan of angle A is equal to the opposite over the adjacent, which is equal to 5 over 12. Okay? 5 over 12 is the tan of angle A. If that's all your problem asked you to find, that would be your answer. But what we want to find is we actually want to know what angle A measures. Okay? So we go to our calculator. Which one of my trig functions do I want? I don't want tan.
Inverse.
I want tan inverse. And what am I gonna put inside of this parenthesis? I'm gonna put 5/12, control divided by. And then press enter, and it says, oh, that angle measures about 22.62. Okay, what'd you get? Okay, so earlier when I gave you directions to make sure your calculator was in degrees, did you do that? And you did it, so you made sure it said degrees, and then you said make default. Okay, did you pick tan inverse just now? So you have tan inverse of 5/12. All right, so go to your menu. Nope, sorry, I do that wrong. Every time go to document, go to settings, go to document settings, and tell me what that second thing says. There's your problem. Okay, so you gotta set it to degrees. Yep. Okay, if you go back to this page and you arrow up twice, you can grab that and press enter, and it'll give you a different answer now that you've changed your settings. Arrow buttons. Arrows to go up and then enter to grab it. Okay, all right, so what you guys are gonna do today is work on some more problems like this. Some of the problems will be like this one that you see right here. And the problem's directions will say, solve the triangle. What do you think it means it wants you to do if it says solve the triangle? Philip? It does. It wants all the angles and all the sides. Okay? All right, give me...
You're not gonna check our answers?